Hey guys, welcome to Cyber Kitty. In this video, we are going to talk about Caesar Cipher. So it's a pretty simple cipher logic. So what's happening is in order to encode the letters as per Caesar Cipher logic, all we are doing is we are shifting the character's position 13 spaces forward. So basically, to decipher it, which is the function we have to write, all that we need to do is somehow shift the letter's position 13 places backward and get the original letter. A couple of things is that they did mention that all the letters will be uppercase and we do not need to transform anything that's non-alphabetical character. That includes spaces, punctuations, exclamatory marks, anything like that. So those all stay the same. So that being said, let's get started. All right, so if you take a look at this here in the notepad, I did make some notes so it's easy to discuss. So first thing I did is, there you go. These are the letters that we're going to have to decipher. A to Z, all uppercase. I just gave it a position from 1 to 26. Each letter holds a position in alphabetical order, of course. And these are the ASCII values for these letters. So what are ASCII values? ASCII codes is bits and byte representation of each character, and this ASCII chart contains 128 characters. That's 0 to 127. You would see in this table, you could see that there's space, exclamation mark, different kind of punctuation marks, numbers. But we are especially interested in capital letter A till capital Z. And those are the values between 65 and 90. And those are the numbers that you see here, 65 to 90. So forget about deciphering for a second. Let's talk about ciphering itself. How do we work the Caesar cipher, right? So let's just say, for example, for a letter A, if it goes through the Caesar cipher logic, all that happens is the letter A gets shifted 13 positions forward. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 positions forward. So it will be N. So the easier way to actually think about it in the head is, let's talk about a wheel, right? So, for example, at some point, if you think the letters A to Z are represented in a wheel, for this to be ciphered, for this letter to be ciphered, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this letter is what the resulting letter is. So when it comes to deciphering, what happens is there are only 26 letters. So if you think of 26 letters as a wheel, and we just shifted 13 positions from the start point to get to the end point, that is nothing but half of the circle. So at which point, to get from N to A, no matter you go this way or this way, you will still have to pass 13 positions. So let's see, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13th is A. Or you go this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the 13th is A. So when you think of it as a wheel, shifting 13 positions not necessarily means just like minus 13 and you get a number. It can be minus or plus 13 and you will still end up with that deciphered number, provided you're thinking of it as a wheel, right? But if you look at these values, these are linear values. They are going from 65 to 90, and these are nowhere connected in a wheel if you're thinking of them as in a mathematical order, right? They're going in a linear point of view. So, how do we attain this logic? If you look closely, you could see that up to 78, from 78 to 90, if these are already cipher letters, all you have to do is minus them with the 13 to get up to 65. The reason why I said 78 is because if you take a look at 77 and you do minus 13, you'll end up with 64, and that is out of this value. So what happens with 64? Take a look here. 64 is an add character, and we don't want that. What we want instead is we want it to go till 65 and loop through to Z and get 90. So how do we do that? So that's why we only minus 13 until the value is 78. If it is anything after that, all we have to do is, instead of shifting backwards, we shift forward, which is, instead of minusing 13, we just plus 13 and we get the actual values that we want. So for example, 77, so you do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, C. Or if you actually go this way too, you see this is 10, sorry, this is 12, and then the 13th position will be Z. This is a simple way to write the logic to decipher the characters. Okay, so next thing is, how do we get the actual values of converting, let's say, letter A to get the ASCII value of A, or convert 65 to get the character A. For that, these are the two functions that will be helpful. So this will be the string name. So you write the string name, or name of the string variable, and then write this method, character code at, where X is the position. So let's say for a string hello, let's call it str, right? So to get the character code of H in the position 0, which is the index in that string for the letter H, all we have to do is str dot character code at 0. So that's a simple way to write that. And here, all we do is just pass the number or the value. This stays constant, string dot from character code. And the input for this function would always be a number, 85, 90, 65. Depending on what we give, it converts it back to a character. So in this instance, we're just going to give the value between 65 and 90. That's always set, because everything else, as per the logic here, everything else will be not transformed and passed as is. So let's go ahead and start writing up the function. So let's say I'm going to call a result as the array. So I am initiating an empty array. I'm going to start deciphering each character in this string through a loop, and then pushing them back into my result array, and then changing it to string and returning it back. So let's write the return first. Returning result, because at this point this has a bunch of elements in the array. I'm just going to join it to get a string. Perfect. And then return the value. So now, next step is to write a for loop, because I want to loop through each character in that string. So for variable I equal to 0, I less than string dot length plus plus, and then, oh, my bad, string dot length, what was I thinking? It's I plus plus. Okay, so what are we doing here? So we are initiating the variable I to 0, and then I less than string dot length. Make sure at any point, if the I value goes greater than the string length, just stop the loop. So that works out there. And then I plus plus, what that does, it increments the position every time the loop goes through. So we are going to the next position, and after that to loop through each character in the string. So we got that right. So next thing is the first condition. Only do something if it is a letter in this set. If it's not, do nothing. So in order for that to happen, let's just say var temporary. So this is a temporary variable I'm creating, where I'm going to save the ASCII value of the current character in the string. So that would be character code at the position I. So this is a temporary variable I'm saving. So if temporary variable's value is less than, oh, it's greater than or equal to 65, and temporary variable's value is less than or equal to 90, do this. So what we are doing here is we are only going to decipher it if the ASCII value is between 65 and 90. If that's not the case, don't do anything. Just add it to our result array without any change. str I. Perfect. So we're just going to push the element. Let's say when it comes to spaces in this condition, just going to see, uh-oh, the value does not lie in this limits that were given. So let's just push it to the result array without doing anything. So that part's covered. Now this is where shifting back and forward logic comes into picture. So as we discussed earlier, up to this point, shifting forward would not work because it's going to go beyond 90, and the characters beyond 90 are not what we want because that will be like open bracket or slash, and these are not what we want. So when that's why when it is about or equal to 78, we're going to do a backward shifting, and when it is in this set of values, we're going to do a forward shifting. So either way, there are 13 spots to accommodate, and we are not going beyond these two limits. That's the whole point of using two different shifts at this point. Okay, so now let's go ahead and write the logic. If temporary value is greater than or equal to 78, which means they're in the second set of values here, we're going to shift backwards. So all we need to do is result I. This is where we are putting the result variable after deciphering. Is equal to string dot, and now write from character code. And this is where the numerical value comes in. The numerical value is going to be temper minus 13 because we are doing the shift backwards. So to do shift forward, all we do, because once we check that condition, if they're not in the second set, obviously they're in the first set of values. So we can write an else and put the same command code in there. And instead of doing backward shift, we're going to do a forward shift instead. So now once we rejoin the whole array back into a string, this should work perfectly. Let's just run it. There we go. So again, the only little bit confusing part here is how we use the forward and backward shift logic. This works fine just because there are 26 characters and the shift cipher uses the 13 position shift. That means at any point on both sides of the circle, you have the same number of spots. That's how I use the forward and backward shift logic here. Again, we use from character code to convert the numerical value, ASCII value back into a character, and then character code at, and then the position to change an actual character back into an ASCII value. This is a little bit about how Caesar Cipher works out. I really hope you enjoyed this video. If you did, please do hit that like button and do subscribe to my channel, Cyborg Kitty. I will see you on my next video with some more coding challenges. Until then, have fun coding, guys. Bye.